Hi everyone, my name is Mark, and in this video, I'm going to be going over every formula you must know for the SAT math section. First, I'm going to be explaining the formulas that are given to you at the beginning of each part of the math section. If you don't remember, there's two parts of the math section. One part, you can use a calculator, but the other part, you can't use a calculator. It would be helpful if you memorize these formulas because if you need to use one of these formulas, you won't need to flip to the beginning of each part to look up the formula if you memorized it. Therefore, by memorizing these formulas, you can save yourself some time, and this time can be used to go over your answers once you answer each question. So the first formula that's given to you is the formula for the area of a circle, which is A equals pi r squared, where A represents the area of a circle, pi is a constant which is equal to approximately 3.14159, and r represents the radius of the circle, as you can see in the example circle above the formula. The formula to find the circumference of a circle is C equals 2 pi r, where C represents the circumference of a circle and r represents the radius of the circle. The formula to find the area of a rectangle is A equals L times W, where A represents the area of a rectangle, L represents the length of the rectangle, and W represents the width of the rectangle. The formula to find the area of a triangle is A equals 1/2 times B times H, where A represents the area of a rectangle, B represents the base of the triangle, and H represents the height of the triangle. The Pythagorean Theorem states that C squared equals A squared plus B squared, where A and B represent the sides of a right triangle, and C represents the hypotenuse of the right triangle. If you know the value of two of these variables, then you can solve for the third variable using the Pythagorean Theorem. On the SAT, you're given information about two special right triangles. One of these special right triangles is the 30, 60, 90 triangle. 30, 60, 90 triangles are right triangles with angles that measure 30 degrees, 60 degrees, and 90 degrees. In addition, each 30, 60, 90 triangle has the same ratio of sides from shortest leg to longest leg to hypotenuse, which is x to x times the square root of 3 to 2x. The second special right triangle that you're given information about is the 45, 45, 90 triangle. 45, 45, 90 triangles are isosceles right triangles with angles that measure 45 degrees, 45 degrees, and 90 degrees. In addition, each 45, 45, 90 triangle has the same ratio of sides from one of the legs to the other leg to the hypotenuse, which is x to x to x times the square root of 2. The formula to find the volume of a rectangular solid is V equals L times W times H, where V represents the volume of a rectangular solid, L represents the length of the rectangular solid, W represents the width of the rectangular solid, and H represents the height of the rectangular solid. The formula to find the volume of a cylinder is V equals pi r squared H, where V represents the volume of a cylinder, R represents the radius of the base of the cylinder, and H represents the height of the cylinder. The formula to find the volume of a sphere is V equals 4/3 pi r cubed, where V represents the volume of a sphere and r represents the radius of the sphere. The formula to find the volume of a cone is V equals 1/3 pi r squared H, where V represents the volume of a cone, r represents the radius of the base of the cone, and h represents the height of the cone. The formula to find the volume of a pyramid is V equals 1/3 times L times W times H, where V represents the volume of a pyramid, L represents the length of the base of the pyramid, W represents the width of the base of the pyramid, and H represents the height of the pyramid. So, you're also given several rules on the SAT. So one of the rules is the number of degrees of arc in a circle is 360. The second rule is the number of radians of arc in a circle is 2 pi. And the final rule is the sum of the measures in degrees of the angles of a triangle is 180. Now, I'm going to be explaining formulas that are not given to you on the test. So, a quadratic equation can take multiple forms. The first form it can take is the standard form, which is y equals ax squared plus bx plus c, where c is the y-intercept of the parabola, and a, b, and c are constants. Negative b over 2a is the x-coordinate of the vertex of the parabola. Remember that the graph of a quadratic is a parabola. The second form a quadratic equation can take is the vertex form, which is y equals a times parenthesis x minus h parenthesis squared plus k. hk is the vertex of the parabola, and a is a constant. The third form that a quadratic equation can take is the factored form, which is y equals a times parenthesis x minus p parenthesis times parenthesis x minus q parenthesis. P and q are the x-intercepts of the parabola, and p plus q over 2, which is the midpoint of the x-intercepts, is the x-coordinate of the vertex of the parabola. The FOIL method is used to multiply two binomials. Here's what each letter in FOIL represents. F represents multiplying the first terms of the binomials. O represents multiplying the outer terms of the binomials, so the first term of the first binomial and the second term of the second binomial. I represents multiplying the inner terms of the binomials, so the second term of the first binomial and the first term of the second binomial. And L represents multiplying the last terms of the binomials. Here's the FOIL method in action. So we have parenthesis x plus a parenthesis times parenthesis x plus b parenthesis. So we multiply the terms that represent f, so x and x, to get x squared. Then we represent the terms that represent o, so b and x, to get bx. Then we multiply the terms that represent I, which are a and x, to get ax. Then we multiply the terms that represent L, which are a and b, to get ab. And then we end up with x squared plus bx plus ax plus ab. And that's the result when you multiply those two binomials. So there's some special factoring rules you should know. The first is the difference of two squares rule. So x squared minus y squared equals parenthesis x minus y parenthesis times parenthesis x plus y parenthesis. You should also know the perfect square trinomials rules. So there's two. The first one is when the two terms in the binomial are being added. So parenthesis x plus y parenthesis squared equals x squared plus 2xy plus y squared. The second version is when the two terms in the binomial are being subtracted. So parenthesis x minus y parenthesis squared equals x squared minus 2xy plus y squared. You should also know the quadratic formula, which is x equals negative b plus minus the square root of b squared minus 4ac over 2a. The quadratic formula is used to find the roots of a quadratic equation if it isn't easily factorable. To find the values of a, b, and c to substitute into the quadratic formula, the quadratic equation must be in standard form. And recall, standard form is y equals ax squared plus bx plus c. The discriminant is equal to b squared minus 4ac. The discriminant is the expression that's under the square root in the quadratic formula, which recall is x equals negative b plus minus the square root of b squared minus 4ac over 2a. Therefore, to find the value of the discriminant of a quadratic equation, the quadratic equation must be in standard form, y equals ax squared plus bx plus c. The value of the discriminant can be compared with 0 to find out how many and what type of solutions a quadratic equation has. So if the discriminant is greater than 0, the quadratic equation has two distinct real solutions. If the discriminant is equal to 0, the quadratic equation has one real solution which is repeated twice. If the discriminant is less than 0, there are no real solutions, but there are two imaginary solutions which will be conjugates or imaginary numbers with opposite signs. There is a simple way to find the sum of the roots of a quadratic. You first must make sure that the quadratic is in standard form, ax squared plus bx plus c. Then, using a and b from the quadratic, you find the value of negative b over a. The result will be the sum of the roots. There's also a simple way to find the product of the roots of a quadratic. Just like when finding the sum of the roots of a quadratic, you first must make sure that the quadratic is in standard form, ax squared plus bx plus c. Then, using a and c from the quadratic, you find the value of c over a. The result will be the product of the roots. So there's multiple forms that a linear equation can take. The first form is the slope-intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept. The second form that a linear equation can take is the point-slope formula, which is y minus y sub 1 equals m times parenthesis x minus x sub 1 parenthesis, where m is the slope and x sub 1, y sub 1 is a known point. The third form that a linear equation can take is the standard form, which is ax plus by equals c. So you can find the slope of the line from this form by calculating negative a over b. You could also calculate the y-intercept by calculating c over b. And finally, you can calculate the x-intercept of the line by calculating c over a. Therefore, if you're given the standard form of linear equation, you don't need to convert the equation to slope-intercept form to find the slope or the y-intercept. A linear equation can also be a horizontal line, which would be represented by y equals b, where b is a constant. Lastly, a linear equation can also be a vertical line, which would be represented by x equals a, where a is also a constant. So the slope formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The slope formula is used to find the slope of a line by substituting 2 points, x sub 1, y sub 1, and x sub 2, y sub 2, into the formula and simplifying. Here's a different result that can result from the slope formula. If the slope is positive, the line is increasing vertically as x increases. If the slope is negative, the line is decreasing vertically as x increases. If the slope is 0, the line is a horizontal line. If the slope is undefined, the line is a vertical line. The distance formula is d equals the square root of parenthesis x sub 2 minus x sub 1 parenthesis squared plus parenthesis y sub 2 minus y sub 1 parenthesis squared. The distance formula is used to find a distance between 2 points, x sub 1 y sub 1 and x sub 2 y sub 2. You don't necessarily need to know this formula because you can find the distance between 2 points by using the Pythagorean Theorem, which is a squared plus b squared equals c squared. Here's how you'd go about doing this. A right triangle can be created with 2 points, where one of the legs represents the horizontal distance between the 2 points, and the other leg represents the vertical distance between the 2 points. Thus, the hypotenuse would be the distance between the 2 points, so you would solve for the hypotenuse using the Pythagorean Theorem to find the distance between the 2 points. The midpoint formula is parenthesis x sub 1 plus x sub 2 parenthesis divided by 2 comma parenthesis y sub 1 plus y sub 2 parenthesis divided by 2 parenthesis. So the midpoint formula finds the halfway point between 2 points, x sub 1 y sub 1 and x sub 2 y sub 2. In other words, if a line segment is drawn between the 2 points, then the midpoint formula finds the point that's exactly in the middle of the line segment. So there's a few exponent and root rules that you should know. So the product rule for exponents states that a to the power of x times a to the power of y is equal to a to the power of x plus y. The quotient rule for exponents states that a to the power of x over a to the power of y equals a to the power of x minus y. The power rule states that parenthesis a to the power of x parenthesis to the power of y is equal to a to the power of x y. The power of a product rule states that parenthesis ab parenthesis to the power of x equals a to the power of x times b to the power of x. The power of a fraction rule states that parenthesis a over b parenthesis to the power of x equals a to the power of x over b to the power of x. The zero exponent rule states that a to the power of 0 equals 1. If you're given a negative exponent in an expression, such as a to the power of negative x, it's equal to 1 over a to the power of x. The fractional exponent rule states that a to the power of x over y is equal to the y root of a to the power of x, or a to the power of x over y is equal to parenthesis the y root of a parenthesis to the power of x. The product rule for roots states that the n root of x times y is equal to the n root of x times the n root of y. And the quotient rule for roots states that the n root of x over y is equal to the n root of x over the n root of y. Remember that 180 degrees is equal to pi radians. To convert from degrees to radians, multiply the degrees by pi over 180. To convert from radians to degrees, multiply the radians by 180 over pi. You must know the following trigonometric functions for the SAT. X in the below trigonometric functions represents the measure of the angle, which can be in degrees or radians. So sine of x is equal to opposite over hypotenuse. Cosine of x is equal to adjacent over hypotenuse. And tangent of x is equal to opposite over adjacent. Now, I'm going to be going over the complementary angle relationship between sine and cosine. So in degrees, it states that sine of theta is equal to cosine of 90 degrees minus theta, and cosine of theta equals sine of 90 degrees minus theta. In radians, it states that sine of theta is equal to cosine of pi over 2 minus theta, and cosine of theta is equal to sine of pi over 2 minus theta. Remember that 90 degrees equals pi over 2 radians. So here's the proof of the complementary angle relationship between sine and cosine. So here's a right triangle with theta and 90 degrees minus theta labeled, and opposite, adjacent, and hypotenuse labeled, and they're relative to the angle labeled theta. And we can see that sine of theta is equal to opposite over hypotenuse, and cosine of 90 degrees minus theta is equal to opposite over hypotenuse. So they're both equal to the same thing. Pythagorean triples are sets of integers that make the Pythagorean theorem a squared plus b squared equals c squared true, and are written in the form of a to b to c, or parenthesis a comma b comma c parenthesis, or a dash b dash c. Therefore, Pythagorean triples are the sides of right triangles. There are two Pythagorean triple triangles that you need to know for the SAT. The first one is the 3, 4, 5 Pythagorean triple triangle, and the second one is the 5, 12, 13 Pythagorean triple triangle. Knowing these Pythagorean triple triangles can eliminate the need to use the Pythagorean theorem. In addition, the above Pythagorean triples can be written in different forms. For example, 3, 4, 5 can be written as 6, 8, 10. Each number was just multiplied by 2. The sum of the interior angles of a polygon is equal to parenthesis n minus 2 parenthesis times 180, and n represents the number of sides. The measure of a single interior angle of a regular polygon is equal to parenthesis n minus 2 parenthesis 180 over n, and again n represents the number of sides. So the equation of a circle is parenthesis x minus h parenthesis squared plus parenthesis y minus k parenthesis squared equals r squared. HK is the center of the circle, and r is the radius of the circle. Recall that an arc of a circle is a part of the circumference of the circle, and a sector is part of the area of a circle, and it's enclosed by 2 radii. So the formula to find the length of an arc of a circle is length of arc equals central angle over 360 times 2 pi r. And the formula to find the area of a sector in a circle is area of sector equals central angle over 360 times pi r squared. The central angle is represented by n degrees in the diagram to the right. Radians can be used, but 360 will have to be rewritten as 2 pi. Notice that 2 pi r is the circumference of a circle, and pi r squared is the area of a circle. So you're multiplying the circumference or the area of the circle by the proportion that the arc or sector takes up in the circle. If you understand the above point, you don't necessarily need to memorize the above formulas. Mean is equal to sum of all the values divided by the number of values. The mean of a set of values is simply the average of the set of values. In addition, it's a measure of center. Basically, to find a mean, you must add all the values and divide the sum by the number of values. If you understand this, you don't need to necessarily memorize the above formula. A real-world example of the mean formula is the formula for speed, which is average speed equals total distance over total time. So there's some other measures of center, and there's some measures of spread that you should also know. The median of a set of values, which is in ascending or descending order, is the middle value of the set. If there's an even number of values, then the median is the mean of the two middle values. If there's an odd number of values, then the median is simply the middle value. The mode of a set of values is the value that appears the most. However, there can be multiple modes if several values appear the same number of times. In addition, there can be no mode if every single value appears the same number of times. The range of a set of values is the difference between the largest value and the smallest value. Standard deviation measures the spread of a set of values. You won't need to calculate the standard deviation of a set of values on the SAT, but you need to understand the following about standard deviation. A low standard deviation means that there isn't much spread. A high standard deviation means that there is significant spread. You should also understand that if a certain number is added to each value in a set of values, the mean and median would change by that number, but the standard deviation, range, and mode would remain the same. So the probability of an outcome is equal to the number of desired outcomes divided by the total number of outcomes. Here's what the different values of the probability of an outcome represent. A probability of 1 indicates that the outcome is guaranteed to occur. A probability that's greater than 0.5 and less than 1 indicates that the outcome is likely to occur, but it's still possible that it might not occur. A probability less than 0.5 and greater than 0 indicates that the outcome is unlikely to occur, but it's still possible that it can occur. A probability of 0 indicates that the outcome will never occur. Exponential equations on the SAT will come in the form of y equals a b to the power of x, where a represents the initial value or y-intercept, and b represents the growth or decay factor, a positive number that is greater than 0 and greater or less than 1, where a b value that's greater than 1 represents growth as x increases, and a b value that's less than 1 represents decay as x increases. B can be represented by 1 plus minus r, where r represents the rate or percentage written as a decimal that something is increasing or decreasing by. So, recall that part over whole equals percent over 100. The above proportion is used to solve for the part of a whole, the whole that a part is of, or the percent that a part takes up of a whole. The proportion can be rewritten so that you can solve for the percent change of a change in the original value, the change in the original value, or the original value. So it would become change over original equals percent change over 100. The triangle inequality theorem states that for a triangle to be formed, the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So here's a triangle with its sides labeled as A, B, and C. So A plus B must be greater than C. And recall that these variables also represent the lengths. And A plus C must be greater than B, and B plus C must be greater than A. Knowing these formulas can be very helpful for the math section of the SAT because they are either required to find the answer to a question or they can save time when finding the answer to a question. If you have any questions, make sure to leave a comment down below. If this video was helpful to you, I'd appreciate it if you liked the video and share it with anyone who might find the information in this video helpful. And thank you for watching.